exponent rules. This is something that you may have seen before, so hopefully this is just a refresher, but if not, we're going to go through them in depth. The first that we're going to take a look at is when we multiply two different things that have the same base. So in this case, they both have the base of x to the a times x to the b. We want to add those exponents. That's x to the a plus b power. All right, let's try power to a power. That also involves multiplying, but it's a little bit different because we have a power raised to another power. So in this case, we have x to the a power all raised to the b power. Whenever we have this one, we want to multiply those exponents. So x to the a times b power. When we divide, so say we have x to the a over x to the b, notice we added when we multiplied, so when we divide, we're going to subtract. So that would be x to the a minus b power. Okay. Just a couple terminology things wise, so we kind of know if we have an exponent of 0, anything to the 0 power is 1. We also do not like negative exponents, so if we have x to the negative a power, we want to move that down. That would be equivalent to 1 over x to the a. So if we have a negative exponent, we always want to get rid of that. It's kind of a mathematical no-no, so we want to get rid of that. We want to move it either up or down depending on where it is in a fraction. Okay. Also, really quick, just a reminder, your roots are fractional powers. Let's say we have the square root of x. That's the same as x to the 1/2. Okay, if we had, for example, the cube root of x, that's x to the 1/3. Okay, so those root powers are fractions, and the root is what goes on the bottom of the fraction. So if you have, just like we had here, if we had square root, that's x to the 1/2. The 2 is on the bottom of the fraction. The cube root of x, that's x to the 1/3. The 3 is on the bottom of the fraction. If you had fourth root, then that would be x to the 1/4. Okay, so the root follows the bottom of the fraction. All right, let's take a look at some examples. Here we want to simplify. We only want positive exponents. So if we end up with any negative exponents, we have to move them, remember. So let's go through this. The first one here, we have x to the 4th to the negative 3rd power. That's what we need to take care of first. We have a power to a power. Remember we said power to a power we have to multiply. So x to the 4th raised to the negative 3 becomes x to the negative 12 when we multiply. And we still have 2x to the 4th that we're going to multiply by. Now, this x to the negative 12th, that's just like 1x to the negative 12th, right? A coefficient of 1 out front. So 1 times 2 is still 2. And then we have x to the negative 12 times x to the 4th. This is when we add our exponents. We have the same base of x, so we want to add our exponents. Negative 12 plus 4 gives us negative 8. Okay, we only want positive exponents, so we got to move it. It's on the top right now, so we could put it on the bottom and make it positive. So this final answer would be 2 over x to the 8th power. All right, now let's take a look at this next one. We've got a lot going on here. We have 3 things being multiplied on the top, and then we have to do a division. For ones like this, you want to do any operations that you have on the top and any operations on the bottom, and then you want to divide. So in this case, we don't have any operations on the bottom. Let's go ahead and do everything on the top. Let's look at our coefficients. We have 2, 4, and 3. 2 times 4 times 3 is going to give us 24. Okay. Let's look at our x's. We have x squared, and x to the 1st because it's an x by itself. When we multiply like this, we want to add exponents. So 2 plus 2 plus 1 gives us x to the 5th. Now let's look at our y's on the top. We have y to the 4th times y to the 4th. There's no y in the 3rd term. So we add those exponents, and that would be y to the 8th. On the bottom, we have everything exactly the same. Okay, so now we just want to simplify. Let's take a look at our coefficients. 24 divided by 3 is 8. Let's look at our x's. Okay, we have a negative 3, x to the negative 3 on the bottom. So we want to move that up, right? We want to get rid of that and move that up. So let's think about crossing it out here and multiplying by x to the positive 3 on the top. If we do that, x to the 5th times x cubed is x to the 8th. Now let's take a look at our y's. Our highest power is in the top. We have a y to the 8th. We have a y squared on the bottom. Remember, we subtract. So 8 minus 2 leaves 6. And now we don't have anything left on the bottom. So we just have 8x to the 8th, y to the 6th. Okay, let's try another one. This one, pretty simple and straightforward. Something we need to take care of first on the bottom. We have to square that out, but first, take a look. We have x to the 0 power. We said anything to the 0 power is 1, right? So it's like this is gone. It's just a 1. 2 times 1 is just 2. So on the bottom, we have 2 squared. So in order to simplify, 2 squared is just 4. So we end up with x over 4 as our answer here. Number 4, this is one that looks really difficult, but it actually ends up being pretty simple. Take a look at the top. All of that stuff inside the parentheses, notice it's raised to the 0 power. And we just said anything to the 0 power is 1. So that's just a big 1 on the top. That's it. And then we still have everything the same on the bottom. Okay. And what is it? K to the negative 2. Okay. So now we want to get rid of these negative exponents. Notice that everything on the bottom has a negative exponent except for the 2. So that means we are going to move each of those up to make them positive exponents. So we're going to have an h to the positive 3, a j to the positive 4, and a k to the positive 2. And then the only thing that's going to be left on the bottom is that 2, because that 2 did not have a negative exponent, so we do not move it. And that's, again, one where it looks really complicated when you first look at it, but if you realize, hey, oh, this is just to the 0th power, I should be fine. Okay? Let's try another one. Here we have some multiplication. So we have the first set of parentheses raised to the 3rd power and the second set of parentheses raised to the 2nd power. So let's take care of those first. 3 to the 3rd power is 27. Okay, now let's keep going. Oops, I don't know why I got rid of my, let's erase that. There we go. Okay, let's go back. 27. Now we have x raised to the 3rd power, so that's x cubed. Y to the 2nd power, all raised to the 3rd power. Remember, when we have power to a power, we multiply, so y squared to the 3rd power becomes y to the 6th power. All right. Next, we need to raise these to the power of 2. 2 squared is 4. X squared, all squared. Remember, we multiply the exponents when we have power to a power. So x to the 4th and y to the 8th. Power to a power, we multiply the exponents. So 4 times 2 gives us 8 for that exponent. Now we need to multiply. Look at the coefficients. 27 times 4 gives us 108. Take a look at our x's. We have x cubed times x to the 4th. This is when we add our exponents, so that becomes x to the 7th. Look at our y's. We have y to the 6th and y to the 8th. So this is when we add again the exponents, so that becomes y to the 14th. And that would be our final answer. All right, let's take a look at the next one. We have a fraction we want to simplify. Okay, so 24 over 8 is 3. We can go ahead and simplify that. Now let's take a look at our x's. Highest power of x is in the bottom, isn't it? Okay, so here's how you want to think of these. If we just tried to subtract as it is the exponents because we're dividing, we'd have 9 minus 10, which would give us an x to the negative 1 on top, and we would have to move it to the bottom anyway. So the way I like to think of these is look where your highest power is, subtract your exponents, and then leave them wherever the highest power was. So take a look at these x's. We said the highest power is on the bottom, okay, with an exponent of 10 for x. So let's subtract 10 minus 9 leaves 1, and let's leave it where the exponent was. So that would be x to the 1 or just x on the bottom. Now let's do the same thing with our y's. Take a look at the y's. We have y to the 12th and y to the 6th. The highest power is on the top, so we're going to leave what's left on the top. 12 minus 6 leaves y to the 6th. Now, z, we have a negative exponent on the top. So we know we're going to want to move that anyway. Okay, so we're going to move z squared to the bottom. Okay, so if we have z to the 6 times z squared, that's going to give us z to the 8th. And then our final answer, 3y to the 6th over x z to the 8th. All right, let's take a look at some applications here. Find an expression for the area of the rectangle given. Okay, so when we see one like this, we want to, first of all, we have to know our formulas. So making sure you know formulas, some basic area formulas, basic volume formulas, very important. Area of a rectangle, we have either length times width or base times height, however you want to think of it. So we need to multiply 10a squared b cubed times 4a to the 5th b to the 4th, okay, in order to get the area. So let's do that. Look at our coefficients. 10 times 4 would give us 40. A squared times a to the 5th would be a to the 7th. B cubed times b to the 4th would be b to the 7th as well. Okay, those are pretty simple and straightforward. We were multiplying, so we added our exponents with our a's and our b's. Now let's take a look at the next one. We have a triangle. In this case, 1/2 base times height is our area of a triangle. So let's plug in what we know. 1/2 times the base, which is 2x to the 4th y squared z. And height, whew, I'm running out of room here. I'm going to do this, is 3xyz all cubed. I'm going to actually go ahead and multiply that out to make it a little bit easier on us. So let's think about applying that exponent of 3 to everything. 3 cubed is 27. X now cubed, because it was x to the 1. Y now cubed, and z now cubed. Okay, now we want to do this multiplication. 1/2 times 2 times 27. The 1/2 times 2 is just 1, times 27 is 27. Okay, let's look at our x's. We have x to the 4th times x to the 3rd. This is when we add our exponents, so we end up with x to the 7th. Let's take a look at our y's. We have y squared times y to the 3rd. Add our exponents, that becomes y to the 5th. And then lastly, we have z, which is z to the 1st times z to the 3rd. So that becomes z to the 4th when we add our exponents. So our expression for area of that particular, that looks like a 4, or that looks like a -1. There we go. Of that particular triangle would be 27, x to the 7th, y to the 5th, z to the 4th. All right. Last one to take a look at. We are trying to find an expression for the volume of this prism. So again, important to know, volume of a rectangular prism is length times width times height, right? So let's plug in. We want to multiply all three of these. 4x cubed y squared z times 2x, oops, that's not an x, let's fix that. Okay, 2x y cubed z to the 4th times our height, which is 3x squared y squared z squared. All right, now let's simplify down. Oh dear, that's not area. That's volume. Oops. There we go. Okay. So volume, oops, I got it up here too. Volume, length times width times height. Let's start with our coefficients. 4 times 2 times 3, that would be 24. Okay. I don't know where that came from. Okay, let's get rid of that. Here we go. Now let's take a look at our x's. So we have x to the 3rd power times x to the 1st times x squared. We are multiplying here, so we want to add our exponents. So 3 plus 1 plus 2 gives us 6, the exponent on the x. All right, now let's take a look at the y's. Y squared times y to the 3rd times y squared is going to be y to the 2 plus 3 plus 2, y to the 7th. And then let's look at our z's. We have z, which is z to the 1st times z to the 4th times z squared. So 1 plus 4 plus 2 gives us z to the 7th. So our volume would be 24x to the 6th, y to the 7th, z to the 7th. Okay? Those are quick ways to tell, hey, do I know what I'm doing as far as not only do I know my formulas, but also do I know how to apply these exponent rules. All right, guys, you're going to have plenty of practice with this. Please feel free to reach out if you are struggling with your exponent rules.